Olá a todos e todas que nos acompanham aqui ao vivo pelo canal do GIEM, Grupo de Investigação e Ensino de Matemática, do Departamento de Matemática da Universidade de Brasília. Cumprimento também quem não vai poder assistir hoje, mas que vai estar assistindo essa apresentação no futuro. É com grande satisfação que a gente dá início a mais um seminário em Educação Matemática, que vem acontecendo desde 2016, esse ciclo de seminários promovidos pelo GIEM e que conta com a parceria de vários grupos de pesquisa, como o Grupo de Pesquisa e Investigação em Educação Matemática, o PI, conta com a colaboração também da Sociedade Brasileira de Educação Matemática, em especial a regional aqui do Distrito Federal, além das universidades de Campina Grande, né, a Universidade Estadual da Paraíba e a Secretaria de Estado da Educação do Distrito Federal, que é a minha instituição, né, de onde eu falo. Neste ano, é um ano muito especial para o GIEM está completando 10 anos de existência, do seu cadastro aí como grupo de pesquisa, e ao longo desse período, a gente tem tentado realizar, desenvolver estudos e ações que contribuem para o fortalecimento do campo da educação matemática e para a qualificação do processo de ensino-aprendizagem dos estudantes do Distrito Federal e do Brasil. Hoje a gente vai realizar esse seminário de pesquisa tão especial com esses convidados internacionais e com a mediação do professor Silvano, esse seminário intitulado Mathematical Problem Pose Research, What do you know and where you going? Para mediar junto comigo, então, eu vou chamar aqui o professor Silvano Andrade. Seja bem-vindo, professor Silvano, a gente já agradece ao senhor, ele vai fazer a apresentação dos nossos convidados.
Ok, boa tarde, né, a todos, todas e todos, né, então, muito feliz aqui nesta tarde, né, a gente está fazendo esse debate sobre proposição de problemas, né, de matemática, aqui com o GIEM, da UNB, então, a iniciativa, a gente agradece muito, também cumprimento aí Raimunda, então, como Raimunda já falou, né, então a gente tem esse seminário tópico é Mathematical Problem Pose Research, What do you know and where are we going? Né? Traduzindo, pesquisa de proposição de problemas matemáticos, o que sabemos e para onde estamos indo. Então, no primeiro momento, né, os convidados, o professor Jinfa e o professor Hwang, eles vão fazer a fala, e no final a gente abre para o debate. Vocês podem estar colocando as perguntas no chat. Então, vou fazer aqui inicialmente uma breve apresentação do professor Jinfa, né? O professor Jinfa, inclusive, é bastante conhecido no Brasil, né? Tendo em vista que a grande parte da sua produção em proposição de problemas tem sido usada, né, em pesquisas de mestrado, doutorado e também diferentes grupos de estudo e pesquisa. Então, ele é professor, né, na Universidade de Delaware, inclusive membro eleito, né, da Academia Nacional de Educação, também é membro da Associação Americana de Pesquisa em Educação Matemática, é vice-presidente da Comissão Internacional de Instrução Matemática, o ICME, ele é editor-chefe, né, do Jornal de Pesquisa em Educação Matemática, do NCTM, e o professor Jinfa, né, em âmbito mundial, né, é um dos pesquisadores, né, mais destacado, mais consagrado, e uma produção altamente intensa, né, em proposição de problema. Eu tive, inclusive, a honra, né, de fazer pós-doutorado com ele. Então, Jinfa, good afternoon, welcome, you start now, you do your presentation, please. Jinfa, can you hear me?
I could hear you. Yes, I could hear you.
Okay.
And
you're coming at this afternoon talk in Brazil. I mean, we're very happy if you speak and you start you speak.
Okay, thank you, Silvanio. So can you share the screen right now? So is the slides showing there? Will the audience see the slides? Okay, very good. Yes, that's the slides there. Okay, so Stephen, you will start to move, I guess. You listened. Okay, so Stephen and I are going to make this presentation together. And so we will take a turn to talk to you. First of all, I would like to thank Silvanio for inviting us to this sharing. So we are going to also acknowledge the support from the National Science Foundation. Oh, I could control. Okay, Stephen. So you don't. So you are currently in control of the slide, I think. Okay, I will do the control. Let me see. All right. No, I couldn't control. Stephen, do you control or I control? I couldn't control it. So you don't do anything. Let me try. You don't. Let me try. Okay. No, I couldn't control it. Some reason I couldn't control it. Stephen, so you have to control it. Oh, I can now. Are you moving or I'm moving? Uh-oh, Stephen. No, I am. Oh, go ahead. So continue to the NSF slides. No, I'm no longer able to. Really? Oh, I can now. Okay. So first of all, we would like to acknowledge the support from the National Science Foundation for this project. And we have a big team to work on it. So I also would like to acknowledge my team members. We work on this together. So we're going to share with you in 6 parts. And we're going to go through one by one. I'm going to talk about parts 1 and 2 and part 4. And Stephen is going to talk about part 3, part 5, and part 6. So let me go to the part 1 now. So this is the one of the task a high school 9th grade math teacher shared with his students. Ask them to come up with 2 ordered pairs for the function y equal to 6x plus 5. But in the evening, the teachers sent me email saying that the lesson didn't go well because students simply don't know the order. Why the order is important in the ordered pair. So I give him an idea, says that what if you ask a student to pose a real life scenarios, which this linear function could represent, and then ask a student to pose an easy mathematical problem and a challenging mathematical problem, which can be solved based on your real life scenario. So now I'm going to ask the audience, the participants, to spend 1 minute to think about a scenario before I'm going on. So I'm going to pause for a minute right now. when you write up the scenario, you could share with us in the chat, and the easy mathematical problem and the challenging mathematical problem, you also could share with us in the chat. Okay, I guess I will continue because interaction is difficult right now. So the students in his classroom come up with a variety of the scenarios and a variety of the problems. So here's one of the scenario. So he says that it's the $6 per hour and $5 is a bonus. So the real life scenario is somebody is going to work. Is the number of hours worked and the amount of money earned. Another example is the battery. Purchase a back of battery, $6, and shipping fees are always $5. Then this one is go to gym. $5 membership fee, $6 per visit. And X is the number of the times you go. So the Y equal to total. So that Y this linear function could represent. Now this example is very clearly saying that, even though student couldn't do ordered pair for the linear function, but they could come up with a wonderful scenarios and come up with wonderful mathematical problems fit the linear function, which means that they understand linear function pretty well in this sense. So this to show the value of problem posing. But now I want to go to the part 2. Then because problem posing started with problem posing tasks. So I want to say it's in the usually in classroom instruction, the teachers will set up the instructional tasks. But when teaching mathematics through problem posing, the instructional tasks are problem posing tasks. So let me give you an example here. This is one of the examples about a problem posing task. It says that with the following numbers and symbol, which is 40 and 50, two numbers, and the percent sign, please pose one easy problem and one challenging problem involving percentages. So this is a very typical problem posing task. Now, by problem posing in mathematics education, we refer to several related types of activities, basically two. One is to formulate a mathematical problem based on context. Second is to reformulate reading or expressing a problem based on particular context. So this is very very widely accepted definition about a problem posing. But so I want to give you a quick description about what do we mean about a problem posing by compared to problem solving. Now in this task, left-hand side is a graph dealing with the favorite seasons students have. Right-hand side are two questions asking students to solve or to answer based on the graph. But this is a very typical problem-solving task. But now if I change the direction a little bit, I call the prompt a little bit. Instead of asking two questions, I ask a student to pose one easy math problem, one challenging math problem that can be solved using this information. The information is the left-hand side that graph. Then that's also a typical problem posing task. So let's do a quick comparison. The situation could be the same, but the way we ask students to do would be different. The top one is problem posing, bottom is problem solving tasks. And this is another example. The same situation on the top, but the left-hand side is a problem-solving task, which particularly asks the student to answer 4 questions. Right-hand side is a typical problem-posing task. Now, the problem-posing task involving 2 parts. One is a situation, another is a prompt. Prompt means that what we ask students to do. So let's go back to that example here. So problem situation could be varieties, could be real-life context, could be purely mathematical context, but also could have involving different representations for that. So once again, in this case, it's the left-hand side, the situation is represented using bar graph. But now, the same situation, we could use different prompts. So here I give the 3 prompts here. Prompt A, it says that pose 3 different mathematical problems that can be solved using this information. Or I could ask students to pose 3 mathematical problems with different difficulty levels. 1 easy, 1 moderately difficult, and 1 difficult mathematical problem that can be solved using this information. Or I could say, pose 3 mathematical problems to challenge your teachers to solve. See, same situation, I could use different prompts to ask students. So, but in any case, a prompt posing task involving 2 parts, a situation and a prompt. One of the areas of research is to develop or design prompt posing tasks. Now, in the current textbooks, based on our knowledge, based on our analysis, textbooks include fairly few prompt posing tasks. And also based on my knowledge about the textbook in Brazil, it's the number of problem posing tasks are also very small. So one of the question is that how could we help teachers to develop problem posing tasks? Now in our research project, the 3 strategies have been used to develop or design problem posing tasks. One is that simply based on a problem solving task by deleting question and ask for problem posing. Or start with the initial problem solving task, simply ask students to pose additional mathematical problems. Or we could introduce new situations and pose mathematical problems. Now, those are the 3 very commonly used strategies to develop or design problem posing tasks. But in nowadays, there are a number of the additional strategies that has been developed to design problem posing tasks. So, for example, go back to this example. We simply, based on this problem solving task, we delete that 2 question by adding on the problem posing prompt, then ask a student to pose mathematical problems. So that's exactly the way to pose mathematical problems. This kind of way to design problem posing tasks will add on the teachers a little burden for them to do so. But in design the problem posing tasks, one of the research, or something changed here, in design the problem posing tasks, and there are research going on, is that what kind of situation would be better, and what kind of problem posing prompt would be better. So a series of studies has been conducted to looking at how the problem posing situation impact on students or teachers prompt posing. So here is just a few examples about the research on the impact of situations. But then we could look into further. The particular situation could be structured with numerical information, or the situation could be informal context, or could use very personalized tasks. All those kind of situations have been used to examine the impact of a situation on students or teachers' mathematical prompt posing. So those we already know. We already know. But because of time limitation, I will not go into the very detail about each study. But I'll give you just one quick example, which is done by Leon and Silva in 1997. In this case, a prompt posing situation has specific numerical information or has not specific numerical information. And their finding is that teachers performed better on tasks that included specific numerical information than on tasks without specific numerical information. So this means that if the situation includes very specific numerical information, teachers tend to do much better in their prompt posing for that. So another thing certainly is that a prompt posing task has a situation and a prompt, but the research is also looking at, if prompt matters on students or teachers' prompt posing. And our study and several other studies clearly shows that prompts matters. Prompts matters. In particular, prompts influence depth and the linguistic complexity of the problems students posed. And but even though we know quite a bit already now about the impact of situation and the prompts, but still there are quite a bit of things we don't know yet. So let me give you a few examples. What we don't know. Okay, that's probably the research in mathematics education we should go in terms of research on mathematical prompt posing. So, for example, we don't know much about how students interpret different prompts. For example, we got 3 here. How do they understand each of those so that it will have different impacts? For those kind of research, we don't have that much yet, and we still need to explore for that. And in the Journal of Mathematical Behavior, we published a special issue, particularly looking at the task variables on students and teachers' mathematical prompt posing. So it's in that special issue, we listed the several future research questions. So here I put it down here as an example. For example, how can systematic evaluation of prompt posing situations and the prompts inform our understanding of the relationship between prompt posing processes and the products, as well as the relationships between prompt posing and prompt solving? And the second question, like how do students-related variables interact with task-related prompt posing variables? So all those 4 questions needed further investigation. That's, I hope, the field of math education we could go in the future. Okay, now I will pass along the screen to Sthephen to talk about part 3, to introduce the PPBL instructional model. Sthephen? Silvanio, we need you to change the screen and to the Sthephen. Silvanio, please
Ok.
give the screen to Sthephen.
Ok. Just a moment, please. Sthephen? I try to talk with him, but I don't know where is Sthephen now.
Oh, Sthephen is here.
Okay.
Yep, I'm here. It just told me I was backstage.
Okay.
All right.
Raimunda, do you make some presentation about Sthephen now?
Sthephen, so you would do that.
Sthephen, welcome.
Sthephen is here.
It's nice pleasure. You have this talk in Brazil this afternoon. Okay.
Thank you very much. So if we could show the screen that I am sharing currently, that would be wonderful.
Not yet. You need to share it.
I am currently
the screen again.
I'm currently sharing it, but I can share it again.
Okay.
I'll stop this share, and then I will share another. All right. I am sharing it again.
Okay.
Sthephen, I don't see it here.
Yeah, I have a thing that says that it's sharing, but I don't know if anybody else can see it.
So I feel like that there's central control there because I didn't do anything. They shared. It's not you.
You try again.
So Silvanio, I think in your end, someone is controlling it.
Okay. You need to share the okay. You got now.
Oh, no, wait, that's Jinfa's. That's not mine.
Not you.
Mine is mostly blank right now.
It's not you.
Sthephen, can you use this?
I mean, sure. If you want to control it, that's fine.
So, okay, yeah. Why don't we do that? So you go ahead.
All right. All right. Well, thank you. Well, now is it? Am I controlling it now?
I control it. I get you back.
All right. Well, thanks, Jinfa. So as Jinfa said, problem posing tasks are a key component of teaching mathematics through problem posing. But when problem posing tasks are actually used in instruction, we do have to consider more than just the task. We have to consider the shape of instruction around the tasks. So in other words, we need to consider a model of the processes involved in problem posing based learning instruction. So in our project, we've worked with a PPBL instructional model that has 4 steps. And Jinfa has already discussed the heart of the first 2 steps, which involve the task itself, presenting a problem situation and presenting a problem posing prompt to let students know what they're expected to do. I'm going to focus on the 3rd and 4th steps, where students pose problems And then in response, the teacher and the students have to handle those posed problems. So the third step of the model, I think you're one step ahead of me, Jinfa, but that's okay. The third step of the model, when students pose problems, can happen either individually or collectively with classmates. And this step itself involves a process, which we will discuss in a bit more detail momentarily. The fourth step is also crucial. It involves how teachers and students will handle the students' responses. And what that does is it controls how the posed problems can support the students' learning. All right. So first of all, let's consider the process of problem posing itself. Compared to problem solving, problem posing is a relatively new area of inquiry. And so we are actively theorizing and exploring the processes that underlie problem posing. In problem solving, general frameworks such as Polya's 4 steps have been developed and existed for quite some time. So there's various models of problem-solving processes that have been proposed over the years, going back as far as Dewey in the early 20th century. But for problem posing, as I said, we are still much earlier in the exploratory process, and so researchers are actively working to establish useful models of the problem-posing process. Oh. Have my slides gone away? Oh, there we go. So in terms of that work, there have been 2 main streams of effort towards making sense of problem-posing processes. On the one hand, researchers have studied the kinds of responses that people give to problem-posing tasks, looking at the problems or the non-problems that people pose, and using those to find evidence for the processes that generated those responses. On the other hand, researchers have also tried to more directly investigate the processes. Right. So here's an example from work by Silver and Kai in 1996. It's a driving problem-posing task. And Silver and Kai analyzed responses to this driving task to try to inform their understanding of the underlying problem-posing process. And they found that, for example, when generating multiple problems for a situation like this driving situation, students tend to pose related and parallel problems. And that when they pose multiple problems, later problems tend to be more complex than earlier ones. So this does inform our understanding to some degree of what the process is that students went through to come up with their problems. Often, for example, beginning with surface characteristics before diving into more deep connections in the problem situation. A number of researchers have also effectively employed more direct methods to probe the problem-posing process. And for time limitations, I'm not going to go into detail with all of these, but they have used methods that include clinical task-based interviews, talk-aloud protocols, and even eye-tracking methodologies to see what kinds of information that people are attending to as they pose problems. But overall, the goal of this work has been to develop a structure of phases of a problem-posing process. So Kai and Rott have recently proposed a 4-phase problem-posing process. And the overall structure actually has a number of parallels to the classic steps that Polya had for the problem-solving process. So the phases in this process include orientation, in which the poser must understand the task and its contents. Connection, where the poser begins to explore what connections there are among pieces of information, relationships in the information. Generation, in which the poser expresses the problem in a form that can be communicated. And finally, reflection, which can involve refining that expressed problem and also evaluating it in various ways. So in a little bit more detail, when we think about orientation, the poser is trying to answer a few questions for themselves. What is this situation? What information have I been given? And what do they actually want me to do with this information? Do I notice anything? Is there a pattern? Is there anything that jumps out at me? Once they have oriented themselves to the problem posing task, then they can begin playing with those connections. What do I wonder about this information that I see? Is this related to that? If I notice a pattern, does that always hold? Is it true? Are the relationships I'm seeing valid mathematically? Once some connections have been identified, they can be used to create a problem. And so the poser asks, what do I want to find out? And expresses that in the form of a problem. And finally, once the problem has been posed, oftentimes your initial product is not a polished problem. It is an expression of curiosity, an expression of interest. And so looking back at your posed problem, a poser may optimize it, change the language, make it more precise, check that there's actually a way to solve the problem, in evaluating whether the problem is easy or difficult, whether it's a good problem according to various criteria. So once students have gone through this process and responded to a problem posing task, the PPBL instructional model focuses then on how the teacher and the students together will handle the responses, how they'll make use of those responses to support students' learning. And again, we conceptualize this step as having several sub-steps. In this slide, you can see analyze, select, sequence, and solve. So let me talk about each of those in a little bit more detail. So, Jinfa, could you advance the slide? Thank you. So for the analyze sub-step, what the teacher and students are doing is looking at across the problems, trying to categorize them by various criteria, and also, if necessary, to clarify them. Because as I said earlier, oftentimes an initial expression of a problem is not clear. It needs some further clarification. Then, based on the learning goals of the lesson, you cannot deal with every problem that the students in a class pose. There simply isn't time and resources to do so. So you must select which problems are going to give you the most payoff, that are most related to the learning goals of the lesson. And then once you've selected a set of problems, it's important to consider the sequence in which students attempt to solve those problems. You might want to begin with easier problems and move towards harder ones. Or you may choose a different way to sequence the problems. For example, if there is some conceptual connection, that you begin with one problem that reveals a concept and then move on to another problem that depends on the concept established in the first problem. And finally, students solve the problems and focus in that solving on reinforcing the target math ideas of the lesson. So in our project, we've had to think about how to help teachers think about structuring classroom discourse to implement this handling step in their classrooms. And so one of the things that we have tried to develop is a discussion protocol that embeds the 4 sub-steps that I just explained: analyzing, selecting, sequencing, and solving. And in particular, if you look at this diagram, it emphasizes how the mathematical learning goals of the lesson center the decisions that the teachers and students make when handling those responses. whether it is analyzing them or selecting them or sequencing them, those decisions should be made based on, will they pay off for the mathematical learning goals of the lesson? And then you'll also see that around the diagram, everywhere is connect. Because one of the powerful aspects of problem posing based learning is its ability to help students make connections between mathematical concepts and also with their own knowledge that they bring with them. So that is also always there contextually in the background of this decision-making process of handling students' responses. Now, I'd like to just expand briefly on the process of analyzing students' responses. I mentioned that you can use various criteria to do that kind of analysis. And the classifying process, when you take a set of responses and decide, well, these are this type, these are that type, these are those types, involves, as I said, clarifying ambiguous responses. It's an opportunity to give students to engage in that reflection and to make their mathematical communication more precise. It also helps students to understand what counts as a problem, because some of the ways that you may classify the students' responses are which of these are actually mathematical problems and which are something else. And even unexpected responses, as we will see, can be useful. In 1996, Silver and Kai used this particular system for classifying students' responses to a problem-posing task. So in the middle, we have actual math questions, but students could also have produced non-mathematical questions or statements. The mathematical questions can be further classified by whether they're solvable or not solvable. And for the solvable questions, you can classify the problems by their semantic structure. And you can do linguistic analysis both with solvable and non-solvable problems to see, for example, whether they are based on conditional statements or assignment of values to objects. So let's take a quick look at one concrete example. So this is based on that percent example that Jinfa shared earlier. So students are given the numbers 40, 50, and the percent symbol and asked to pose problems about percentages using those three pieces of information. So here are 6 responses that came out from using this task. And one way that you could choose to classify these is by the kind of mathematical structure that they embed. So for example, number 2 and number 6 both have a similar mathematical structure. There's a beginning quantity, and the solver is asked to find a percentage of that given quantity. In one case, it is 50% of 40. In the other case, it is 40% of 50. But they share a similar mathematical structure. And by doing that classification, it highlights that structure and its connection to the language of the problem. I also mentioned about the need to sometimes clarify problems that are ambiguous or that have other issues. If you take a look at problem 5 in this example, you notice that you have boxes of bananas, and then you have 50% more boxes than the boxes of apples. And the question is how many boxes of apples there are. Well, there's an issue with this problem, which is that you don't get a whole number of boxes if you solve this problem. And highlighting that that happens when you analyze the problem gives an opportunity for the students to recognize the disjunction between the abstract numerical problem and the real life situation where you're just trying to count whole numbers of boxes. And so perhaps you would modify the problem to reduce that issue. Some researchers have begun to study how teachers actually do go about handling students' responses. So for example, Zhang and Kai looked across 22 problem-posing teaching cases, specific examples of problem posing in practice, and looked at how teachers chose to handle their students' responses. And one thing that they found was that the teachers prioritize problems that are aligned with the learning goals of the lesson, just as we highlighted in the discussion protocol. Interestingly, teachers also tend to save harder problems for later, for homework. This is probably reflective of simple time concerns, but you can see in both of these kinds of decisions, prioritizing problems aligned with the goal and saving harder problems for homework, you can see selection happening in prioritizing the problems that align with the lesson goal, analyzing to know which are the harder problems, and sequencing, saving those hard problems for later, for homework. Now, given the time, I'm going to just very quickly talk about this example. So this is a pattern of odd numbers. It's a simple pyramid where all of the odd numbers are listed in sequence, row by row. And students can be asked to look at this pattern and come up with problems related to it. And so I've included several possible problems here. You'll notice they are of different levels of difficulty. Some of them involve simply repeating the pattern, going on and on. Some of them involve simple observations about the pattern, that the row number, for example, is always the same as how many numbers are in the row. But other problems can produce unexpected conclusions. So for example, when asked to find the sum of the numbers in the first 100 rows, if you actually start thinking about how that could be done in a class and ask students to solve that, they can stumble across very sophisticated conclusions. So I will encourage you on your own time to explore this, but there is a beautiful mathematical identity involving sums of squares, square numbers, and sums of perfect cubes that can fall naturally out of playing around with posed problems in this pattern. All right, I will pass it back now to Jinfa to talk a bit about how we might measure change.
Sthephen, I think you continue. You continue is better. So switch back and forth is going to be difficult.
You're back.
Oh, I'm back now? Okay. I thought you asked you to continue. But okay, so yeah, get back to me then. So we have to back and forth a couple of times, which is difficult. Yeah, I text you, so hope you will continue. But it's okay though. Silvanio, you're putting me back, right?
Okay. You got to share the screen?
Yes.
Okay.
Good. That's good. So I'm continuing now.
Perfect.
All right. Thank you, Sthephen, for that. So I will talk about the part 4. Then I will ask Sthephen to finish up the part 5 and part 6 for that.
Okay.
Part 5 is about measuring changes. Now, measuring change is that so our instruction is involving prompt posing, which means that we are using the so-called prompt posing based learning, that instructional model to teach mathematics to the students. But then what kind of changes could we see? So that's what we really look at in our project. So we're measuring changes from 3 aspects. Looking at the teacher's belief changes. Now, this is very, very important because the prompt posing is a relatively new idea to teachers, and how well they buy those ideas into their instruction. That's matters. So we want to look at in our project over the years how their belief changes. Then we're looking at their lessons. From beginning, probably very few prompt-posing tasks, to later, got a lot more prompt-posing tasks. Third is that we look at a student's growth, both cognitively and affectively for that. So in our project, we examined that 3 kinds of changes. So I will briefly mentioning the specifics we're looking at. So first one is that we're looking at teacher changes. Teacher changes. So what we find is that teachers feel a lot more comfortable with prompt posing in classroom after several years involved in the project. And from beginning to the end, the more lessons involving prompt posing. Then in each lesson, they tend to use more prompt posing tasks. So those are very obvious changes in our project teachers. But now we're looking at teachers' views. So one thing we ask teachers to talk about is about their perceived advantages and challenges of teaching mathematics through prompt posing. So here I give you like the teacher's perceived advantages and challenges. So we look at it both from teacher's perspective and also from students' perspective. But within teachers, we're looking at the cognitive, affective, and social. Then for the students, we also look at cognitive, affective, and social. So in our study, we clearly see that teachers see a lot more challenges in the beginning to the much less challenges to the recent years. And they will see a lot more advantages by engaging students into prompt posing. And teachers themselves get very excited about using prompt posing to teach mathematics. So one particular thing I want to talk to you to looking at the changes is that perhaps we could look into it in the future. Now, in one of the studies, we analyzed the modeling tasks. So we analyzed 2 issues involving mathematical modeling, and we analyzed 9 books in the modeling book series. So we want to see how many modeling tasks in those papers involving prompt posing. So here's our findings. So when we analyzed the 2 modeling special issues, 9 books, we identified a total of 213 mathematical modeling tasks included in the special issues and the 9 books. Now, within that 213 modeling tasks, only 12 of them involving problem formulation, which is about 5.6%. So little. So the point I'm trying to making is this. So we could implement mathematical modeling tasks in classroom. However, all the vast majority of modeling tasks do not involve prompt posing at all. Only 12 out of 213 modeling tasks involving prompt posing. But on the other hand, we already see quite a bit of changes already by engaging students in prompt posing. So one of the directions I hope the field of mathematics education we could go is that what if the mathematical modeling truly involving problem posing, involving problem posing. In that way, perhaps we could see a lot more changes, both for teachers and students. So this is I want to make a particular point here that the field of mathematics education could go in the future. So I guess I'm going to get back to Sthephen again to finish up the part 5 and part 6. So then we don't have to switch back and forth. Silvanio, we need your help again to switch back to Sthephen.
Okay, thank you. Thanks for both the technical assist and Jinfa for setting us up to talk a bit about impact. So there's many potential ways that problem posing can have an impact on teaching and learning. I'm going to very briefly share some of the impact that we are seeing in our work. So the number of studies of problem posing have continued to increase over the years, which is wonderful. And there have actually been several meta-analyses over the years that have tried to look across and synthesize those findings. We've actually recently conducted an updated meta-analysis of research on problem-posing interventions. It should be forthcoming in JRME. And in our meta-analysis, we found significant effects of these interventions on cognitive outcomes. And in particular, there were significant and large effects of problem-posing interventions on students' problem posing and students' problem solving, those two cognitive outcomes. At this point, there are still not very many studies, quantitative studies, that have measured affective outcomes, students' affective outcomes. And so at this point, there is not a lot there to do quantitative meta-analysis with. However, of what's there, it is very promising that the evidence seems to support a strong positive effect on affective outcomes as well. And I will provide a little bit of qualitative support for that in a moment. So let us take a look at the next slide here. Okay, so as I said, our meta-analysis has shown that problem-posing interventions seem to have a particularly strong impact, as we might expect, on students' problem-posing performance. And we have seen evidence of that in our own project, comparing students' scores early in the school year and at the end of the school year, looking at problem-posing performance. So, for example, if when given a task with a table of data on animals and the speeds at which they crawl, at the beginning of the school year, we tend to see fairly low-level problems, such as which is the quickest, problems that can be answered by no more than looking at the table and reading off of it. However, as they gain experience in class with problem-posing based learning, as they begin to develop their understanding of what a good mathematical problem looks like and how they can draw connections together in posing those problems, by the end of the year, we begin to see evidence of more complex, higher level problems, such as, can the tortoise beat the spider in a 2,000-foot race if he starts on the 100-foot mark? As you can see, that example involves much more involved, complicated thinking than simply reading information off a table. It is involved issues of speed and time, and also they've added complication in giving the tortoise a head start. So that kind of thinking is what we hope that engaging in extended experience with problem-posing based learning will encourage students to develop. From the teachers in our project, we have also gotten evidence of how problem posing appears to be impacting students' mathematical understanding and problem solving. I won't read through all of these quotes, but I highlighted a few key statements. So after problem posing and coming up with their questions, the students were more focused on the content that they were dealing with, the mathematical content. Teachers are observing that students want to challenge themselves and especially others, their peers and their teachers, to come up with harder problems and not just easy off-the-cuff questions. There's metacognition happening. Students thinking about the mistakes they could make and that other students could make as they think about their problems, and creating problems with those mistakes in mind that could reveal misconceptions. These are high-level engagements with the mathematical content and with the concept of problem solving. Teachers are also reporting very promising reports on student engagement. Not simply are the students involved with what's going on in class, but students taking more responsibility for their own learning and then making connections with the material and their knowledge. One thing that problem posing seems to allow students to do is to really participate no matter where they are in their mathematical level. Even students who come in with a math is hard mindset are able to participate and show the teacher that they have expertise, they have proficiency. Okay, so that takes us to the end of our time. And so I'd like to just take a few moments to conclude with a little bit of summarizing about what we know and to point to a few directions for next steps, where we might want to go from here. So what do we know? As Jinfa reviewed earlier, we know a fair bit about problem posing tasks. Task variables matter. How much structure, how much numerical information, what kind of prompt is used. All of these things affect students' problem posing. And we also know several ways to develop problem posing tasks, some of which are quite simple for teachers to implement. The field is beginning to develop useful frameworks for characterizing the problem posing process, and we're seeing parallels to how those frameworks are useful in problem solving research. And it perhaps is not super surprising that there are parallels, given that there has long been shown to be links between problem posing thinking and problem solving thinking. As I just reviewed, there have been a number of studies now showing clear impacts, positive impacts of problem posing on students' ability to pose good problems, to solve problems, and also potentially to develop more positive affective responses to math. There is at this point still some question about how problem posing may or may not influence students' more general mathematical achievement, but that's a place where we definitely need more study moving forward. Ultimately, what we need is work that will continue to longitudinally investigate how teachers learn to do this kind of teaching, to teach math through problem posing. This work, in our conceptualization of it, really targets teachers' knowledge and their beliefs, as Jinfa stressed earlier, in order to help them learn how they can deploy problem posing in their classrooms, how they can then change their instruction, and ideally, at the end, to improve students' learning of mathematics, which is ultimately the goal that we have in mathematics education research. So moving forward, this is a wide open field. Problem posing is still a young enough area of research that there are many questions that remain to be explored. For example, we still have a very serious lack of existing problem-posing tasks and resources available for teachers to pick up and use. Much of our work in our project has been to help teachers to develop their own tasks, but curricula often do not support teachers in that way, and more work needs to be done in that direction. More work is needed to study both the cognitive processes and the metacognitive processes of problem posing, and especially the burgeoning work in the affective processes of problem posing. We need to continue to explore how to support teachers in this form of ambitious teaching to better understand how problem posing can help them to be better teachers of mathematics. Work is needed to measure teacher change in a concrete way, both in terms of what they do in the classroom and in terms of their belief and knowledge. And we definitely need to still, in a long-term way, look at the effects on students of engaging in problem-posing based learning. How does that long-term affect their mathematical understanding and their affect? And finally, as Jinfa made a point of raising earlier, it is important for us to think about how problem-posing research connects and can be integrated into other areas of mathematics education research, such as research on mathematical modeling. This is a key mathematical process that students, teachers, and mathematicians all engage in. And so problem posing should find a natural home in many different areas of mathematics education. So, in sum, we know something, but there is much yet in front of us. We have many places yet to go. And I encourage all of you to take part of that journey with us. Thank you.
Sthephen, thank you, Jinfa. It's a wonderful speech. We're very happy with this moment. Now I brief a synthesis to the audience and some question. We put this question in the private chat, and you, Steve, you see, people in general, congratulations this moment. Ok. Pessoal, né, a gente vai aqui fazer uma breve síntese para estar continuando, né? Então, o que eu queria aqui destacar, né? Não dá, até porque a gente está com o tempo curto, para fazer uma síntese completa. Mas eu queria aqui pontuar, né? Que a fala do professor Jinfa, né? Então, eu vou pontuar. Então, ele e o Stephen, Hwang, né? A gente aqui conhece mais o Jinfa. Eu tive a oportunidade de conhecer, de dialogar pessoalmente com o Sthephen. Eles trabalham muito em parceria, né? Como vocês viram nessa apresentação, é uma fala muito conectada, né? E então é trazida a experiência aí deles, né? É feito um debate geral, né, sobre o que é proposição de problema, sobre o que é uma tarefa de proposição de problema, né? Ele retoma aí também a literatura internacional, começando inclusive com o Silver, né? Então ele traz lá a perspectiva do Silver, do que é proposição de problemas, né? E retoma também outros autores, e uma preocupação que eles vêm fazendo até nesse projeto que eles têm aprovado, é no sentido de estar desenvolvendo, né, um modelo de proposição de problemas, né? Eles têm muito, nesse modelo, a preocupação de tanto orientar a ação pedagógica, a prática educativa do professor, e também ser um modelo que possa ser desenvolvido nas pesquisas. Então, daí também essa preocupação deles, né, de medir também as mudanças, né, que têm ocorrido a partir desse modelo, né. Então, de modo geral, como a gente está aí com um tempo curto, né, eu faria essa síntese, né, então queria estar chamando a atenção, né, então veja que eles, inclusive, durante a fala, né, eles trazem vários exemplos, né, inclusive começando lá pela função linear y igual a 6x mais 5, né, e comenta, discute, então isso é uma coisa que é forte no trabalho de ambos, tanto de Jinfa, tanto do Sthephen, né, essa preocupação de que a pesquisa, né, ela possa ali estar trazendo horizontes, né, para a prática de sala de aula, para o professor, e o professor também, os dados da pesquisa da sala de aula passa ali, dar suporte à pesquisa. Então, isso é uma preocupação forte de ambos, né, e do grupo também. Inclusive, o ano passado em Chicago, né, teve uma apresentação que não estavam eles dois, apenas o grupo, né? Então tem essa preocupação. Eu vou passar agora para a Raimunda, né? Ela vai fazer uma fala, depois eu falo e a gente já está perto de encerrar. Né? Pode falar, Raimunda.
Silvanio, there are a few questions in the chat.
At this moment, we don't have much time.
Sure.
And you read you see the question, the chat, and you, in general, observation, in general, Jinfa e Sthephen. Raimunda, você iria falar?
Olá,
Jinfa and Sthephen, just a moment, because Dr. Raimunda have a conversation now.
Oh, thank you so much for the explanation, for a good moment for everyone. And eu penso, para fechar um pouco dessa fala também, né, professor Silvanio, destacar o que o professor Sthephen trouxe sobre o que vem para o futuro, né? Isso eu acho que interessa bastante a todo mundo. E ele destacou bastante essa questão da participação dos estudantes, que as pesquisas estão caminhando também para ver as relações mais socioemocionais dos estudantes. Eu acho isso interessante. E aí eu acho que dá tempo da gente fazer alguma pergunta, aproveitar a oportunidade e dizer que no Brasil eu investiguei recentemente problem posing, e com foco mais de elaboração de problema, e gostaria de fazer uma pergunta aos professores. In my research, I observed that the study with more engagement in problem posing tasks when they cause with even a simple way technologic resources. In the sense, how do you see relationship between the type, the prompt, and the potential for student engagement when combination with digital technologies?
Well, it's a great question. We haven't done any study like this, but so my hunch would be, it depends on what kind of digital technologies would be used, which could be very useful tool to be used to present or design problem posing tasks.
Using for include the problem posing you created.
Mm-hmm. That's right. The digital technology maybe could not only serve as like a situation itself to present the problem posing tasks, or sometimes it depends on what kind of digital technology we use. Maybe like a ChatGPT could help us to design problem posing tasks. So which we haven't done much yet.
To address the part of your question, though, about student engagement, I know that in our meta-analysis that's forthcoming, one of the factors that we paid attention to was whether the intervention involved technological support in some way. And it does appear, as in the question, that technology does have a powerful effect on the impact of problem-posing interventions. So I would agree with Jinfa that this is a place where a lot more work is needed, because it is very promising. I will say we have not formally studied this yet, but some of the teachers in our project are using a curriculum platform that has allowed them to use technology to have students share their problems with each other. And just the anecdotal reports we have on that are that the students seem to appreciate that and are enthusiastic about it when they are engaging in problem posing.
Oh, thank you. Thank you. For the question, será que a gente consegue fazer mais uma pergunta, professor Silvano? For mais one question?
Pode fazer, Raimunda. Ele viu também os comentários lá. A gente tá traduzido lá para ele. Aí, mas você pode fazer e eu faço outra que eu tenho aqui.
Ok. Regina Pina, for the GIEM, pergunta. For the question. The problems PPBL institutional model has been adapted in Brazil in students with elementary school students with all interlocutors. What further results have motivated you in these investigations? You understand?
Stephen, do you see the question there?
Yes, yeah. This is the about how PPBL instructional models been used in Brazilian elementary school settings, and so the question is, what further results have motivated us in investigating this kind of thing?
In the future results is. Yes.
I see. Do you want to start, or you want me to start?
Go ahead, please.
Well, so I think the further, it's really talking about the PPBL model, right? It's what's the further work we could do? That's the question, right?
Yeah, it's what is motivating us to continue with this?
Yeah, so it's the model, but the motivator us to do is that how that model actually could be used by teachers to implement problem posing in classroom. So one of the things we are continue doing, and we haven't done yet, we're developing teaching cases. And that model with different kind of teachers and different tasks may be implemented slightly differently. So we hope we could use a set of teaching cases to implement problem posing in classroom. And certainly that model could guide the development of teaching cases. So that's the motivation we are having to further for this PPBL instructional model.
I will add that in terms of results that we are seeing from our project, that the impact that I shared with students' engagement and their mathematical understanding, as well as their problem posing capabilities, are very encouraging to us to continue developing this problem posing instructional model.
I understand. Professor Silvano?
Okay. Jinfa, Steve, I would like to question. The first question is from Aluska. She asked, how long do you think it will take for students and teachers to adapt to this approach? And the other question, what is the difference between problem posing and the PBL? Because sometimes not the same. People don't understand exactly the difference. What's problem posing? What's the PBL approach?
So, Jinfa, I can probably speak to the latter part of the question. So the relationship between problem posing and PPBL is sort of parallel to the relation between problem solving and PBL, problem-based learning. So problem solving and problem posing are things that you do. They are activities. They're mathematical activities, at least in math education. PPBL, problem posing based learning, is the approach to learning that uses problem posing tasks and engaging students in doing problem posing as a way to help them learn mathematics. So PPBL is an approach to learning mathematics. Problem posing is the actual activity of generating problems.
Okay. Jinfa and Steve, I know the question, many questions. For example, Vaina asked how to engage in teaching problem posing when the textbook, most textbook, you find the problem solver, not problem pose.
Mm-hmm.
I would like you final commentaries to the people.
Mm-hmm. Mm-hmm.
Okay.
Do you want to begin?
You beginning.
Uh-oh.
Oh, go ahead. If you are waiting for me?
Yeah, I was just waiting for you to.
So
you decide.
Yeah. So the question is really about textbook.
Mm-hmm.
Only include very few problem posing tasks. But then, we need to develop problem posing tasks in order to implement, right? So that's why I mainly talk about 3 strategies in this afternoon, to develop problem posing tasks. So 2 points I want to make. One point is that we needed to have those kind of strategies to develop problem posing tasks, add very little burden on teachers,
Mm-hmm.
which means that it's very easy for teachers to do.
Mm-hmm.
Okay. So in that regard, teachers, simply could, based on problem solving tasks, remove the question at the end, then add on to the problem posing prompt. That would be a very easy way to do it. In our project, we spend quite a bit of time to work with teachers, but just to implement that strategy for that. Okay, so that's the one. Second is that, some teachers could be very creative. They could use their own ways to develop problem posing tasks. For example, it's that one of the tasks we observed is that a teacher will present a geometric diagram and remove all the questions from textbook, then ask students, what kind of questions do you think the textbook will ask you to answer? Isn't that, natural way also could do it? So the second point is that, allow teachers to use their own ways to develop their comfortable kind of a problem posing tasks. Okay, I'll stop here.
All right.
Okay, thank you so much this afternoon. Raimunda will tell the final word, everyone.
Mais uma vez agradecer, né, a participação de todos nessa live. Muitas perguntas a gente infelizmente não teve tempo de responder, mas a gente repassou para os professores. Thank you for Jinfa, Kai, Sthephen. Obrigada, professor Silvano. E agora a gente dá por encerrada mais esse seminário de educação matemática do Grupo GIEM. Boa tarde a todos e até o próximo encontro.
Thank you very much for having us.
So much.
Bye-bye.
Bye-bye.